The desire to see beyond the naked eye is ancient. Early civilizations stumbled upon a simple truth. Glass, when shaped correctly, could magnify the world around them. These early lenses, often called reading stones, were treasured tools. They allowed scholars to decipher tiny script and artisans to create intricate details. Imagine a world without the ability to magnify. A world where the intricate details of insects or the delicate structure of a leaf remained hidden. These early lenses, while simple, opened a window into a previously unseen realm. They sparked a curiosity that would drive centuries of invention. The invention of spectacles in 13th century Italy marked a significant leap forward. Suddenly, poor eyesight was no longer an insurmountable obstacle. This innovation set the stage for further exploration into the world of magnification. The thirst for knowledge about the miniature world was growing. The 16th century brought about a revolutionary invention, the compound microscope. Hans and Zacharias Janssen, a father-son duo of Dutch spectacle makers, are credited with this breakthrough. Their device used two lenses aligned within a tube. This arrangement significantly increased the magnifying power compared to a single lens. The first compound microscopes were rudimentary. They suffered from blurry images and limited magnification. However, they represented a monumental leap forward in our ability to perceive the microscopic world. The Janssen's invention marked the birth of a scientific revolution. News of this invention spread rapidly through Europe. Scientists and natural philosophers were eager to explore the possibilities offered by this new tool. The compound microscope quickly became an indispensable tool for those seeking to unravel the secrets of the natural world. Antonie van Leeuwenhoek, a Dutch draper with an insatiable curiosity, took the compound microscope to new heights. Self-taught in lens grinding, he crafted single-lens microscopes of astonishing quality. His meticulous craftsmanship resulted in microscopes that were far superior to the compound microscopes of his time. With his powerful lenses, Leeuwenhoek embarked on a journey of discovery. He was the first to observe single-celled organisms, which he called animalcules. His detailed drawings and descriptions of bacteria, protozoa, and even sperm cells astonished the scientific community. Leeuwenhoek's discoveries challenged the prevailing scientific dogma of the time. His observations provided the first concrete evidence of microscopic life, paving the way for the fields of microbiology and cell biology. His simple microscopes had revealed a hidden world teeming with life. Throughout the 18th and 19th centuries, the microscope underwent continuous refinement. Lens makers grappled with the challenges of chromatic and spherical aberration. These optical distortions limited the clarity and magnification of the microscopes. Improved glass formulations and lens-making techniques slowly enhanced the quality of the images. One name that stands out in this era is Carl Zeiss. A German engineer and entrepreneur, Zeiss revolutionized the production of microscopes. He applied rigorous scientific principles to lens design and manufacturing. His company, Carl Zeiss AG, became synonymous with high-quality optical instruments. Zeiss's contributions went beyond just improving existing designs. He collaborated with scientists and incorporated their feedback into his instruments. This collaborative approach led to specialized microscopes tailored for specific scientific disciplines. The microscope was evolving from a curiosity into a precision scientific instrument. Section 5. The dawn of microscopy as a science. The late 19th and early 20th centuries witnessed a golden age of microscopy. Advancements in optics and the development of new staining techniques revolutionized our understanding of cellular structures. Scientists could now observe the intricate details of cells and tissues with unprecedented clarity. The field of histology, the study of tissues, blossomed during this period. Scientists used microscopes to identify different types of cells and study their organization within tissues. This knowledge proved invaluable for understanding the development, function, and diseases of various organs. The impact of microscopy extended far beyond biology. Geologists used microscopes to analyze rock and mineral samples. Materials scientists peered into the microstructures of metals and alloys. The microscope had become an indispensable tool in a wide range of scientific disciplines. Section 6. Beyond the limits of light, the electron microscope. The early 20th century brought about a fundamental limitation of light microscopy, the wavelength of visible light. No matter how precisely a lens is crafted, it cannot resolve objects smaller than the wavelength of light used to illuminate them. This limitation meant that certain structures within cells remained frustratingly out of reach. In 1931, Ernst Ruska, a German physicist, shattered this barrier with the invention of the electron microscope. This revolutionary instrument utilized a beam of electrons instead of light to illuminate specimens. Electrons, with their significantly shorter wavelengths, allowed scientists to achieve magnifications and resolutions previously unimaginable. The impact of the electron microscope was immediate and profound. For the first time, scientists could visualize viruses, the intricate machinery within cells, and even individual molecules. The invention of the electron microscope ushered in a new era of discovery, pushing the boundaries of our understanding of the building blocks of life. Section 7. Illuminating the microscopic world. Fluorescence and confocal microscopy. The latter half of the 20th century saw a surge in the development of new microscopy techniques. Fluorescence microscopy harnessed the power of fluorescent dyes, which emit light when excited by specific wavelengths. This technique allowed scientists to target and visualize specific molecules or structures within cells, providing invaluable insights into cellular processes. Confocal microscopy, another groundbreaking invention, addressed the issue of out-of-focus light in thick specimens. By using a pinhole to eliminate light from out-of-focus planes, confocal microscopy produced stunningly clear three-dimensional images of cells and tissues. These advancements transformed the field of cell biology. Scientists could now observe the dynamic interactions of molecules within living cells. They could track the movement of organelles and study the complex signaling pathways that govern cellular functions. Section 8. Microscopes in the 21st century and beyond. The 21st century has witnessed an explosion in microscopy innovation. Super-resolution microscopy techniques have broken the diffraction barrier of light, allowing scientists to visualize objects smaller than 200 nanometers. These techniques have revolutionized our understanding of cellular structures and processes. Atomic force microscopy, or AFM, goes beyond simply visualizing the microscopic world. This technique uses a tiny probe to scan the surface of a specimen, providing information about its topography, mechanical properties, and even chemical composition. AFM has applications in fields ranging from materials science to nanotechnology. The miniaturization of microscopes has led to the development of portable and even handheld devices. These advances are bringing the power of microscopy to new frontiers, from field research in remote locations to point-of-care diagnostics in medical settings. Section 9. A legacy of discovery. The enduring impact of microscopes. From the simple lenses of antiquity to the sophisticated instruments of today, the microscope has played a pivotal role in shaping our understanding of the world around us. It has unveiled a hidden universe teeming with life and revealed the intricate machinery that governs life itself. The impact of microscopes extends far beyond the realm of science. Medical diagnoses, forensic investigations, materials engineering, and countless other fields rely heavily on microscopes. These instruments have become indispensable tools for solving crimes, developing new technologies, and improving human health. As we venture further into the 21st century, one thing is certain: the microscope will continue to play a vital role in shaping our future. With each new innovation, we gain a deeper understanding of the universe, from the smallest atom to the grandest galaxy. The quest to see the unseen, ignited by those early lenses, continues to drive us forward on a journey of endless discovery.